Hi, everyone. My name is Dasmer Singh, and I work at Venmo, and I'm visiting from New York this week. Today, I'm going to talk to you about code reuse across platforms. But before we do that, let's take a quick walk down memory lane. On January 24th, 1984, Apple released the Macintosh 128K. It came with macOS 1.0. Back then, the operating system was just called System. Then, over 23 years later, the iPhone was released on June 29th, 2007, with an operating system called iPhone OS, later renamed to iOS. The iOS App Store, Apple's first modern-day app store, was released on July 10th, 2008. 2 years later, on April 3rd, 2010, Apple released the iPad. It also ran iOS, just like the iPhone. Any app on iPhone would also work on iPad. And given that you use auto layout, it was very simple to make a universal app all with just one code base. Finally, last year, Apple released the Apple Watch and the Apple TV, which run two brand new operating systems, watchOS and tvOS. In total, 4 operating systems, 4 app stores. Apple has given us the SDKs and tools to build for devices in your office, in your pocket, on your wrist, in the living room. The hardware have a plethora of sensors, including accelerometers, heart rate monitors, GPSs, cameras, etc. As developers, that is a lot of power that we've been given. So, as developers, how are we using that power? Are we building for all of these platforms, or just one? Well, the data shows that we're probably just building for iOS, which has 2.3 million apps. Apple Watch and Apple TV have 10,000 and 1,000 apps in their respective app stores. Granted that these OSs are relatively new, and Mac has 30,000 apps. These numbers are probably not very surprising. The iOS App Store has been around the longest, and the number of people that use iPhones is a lot more than the number of people that use Macs, Apple Watch, and Apple TV. Especially given the heightened demand for iPhone apps, developers may not believe that it's worth learning how to write apps on other platforms. But did you know that if you already know how to write iOS apps, writing apps for other platforms is probably much easier than you think? Writing apps for an OS requires you to know the language and the SDK's API. Well, you already know Swift and the Swift standard library. What's left to learn are frameworks specific to each platform. Thankfully, OS X, watchOS, and tvOS SDKs share many, many frameworks with iOS. Writing tvOS apps is probably the easiest for a primarily iOS developer. And that's because both SDKs are extremely similar, especially given that tvOS has UIKit. That enables you to use UI view controller, UI views, UI table views, etc. in your tvOS app. In fact, some simple iOS apps can also be run as tvOS apps without changing even a single line of code. We'll talk more about that in our demo. tvOS's app lifecycle and different states, such as active, inactive, background, suspended, not running, are also the same as iOS's, as is most of the UI application delegate protocol. So some of the common frameworks that are in both iOS and tvOS are UIKit, Foundation, Core Location, Core Data, MapKit, SpriteKit, AV Foundation, Core Media, Media Player, and many, many more. Writing for watchOS is definitely not as familiar to an iOS developer as is writing for tvOS because it lacks UIKit in favor of watchKit. WatchKit has many similar paradigms as UIKit, such as WK interface label instead of UI label, and WK interface table instead of UI table view. But they are definitely much more limited in scope, as you would expect from an SDK built for a device on your wrist. You'll also find a number of other iOS frameworks you can use on watchOS, and these include Foundation, Core Motion, Core Location, Core Data, HealthKit, HomeKit, PassKit, and Contacts. Similarly, OS X substitutes AppKit for UIKit, increasing the learning curve when compared to tvOS. Still, there are quite a large number of core libraries that are shared amongst OS X and iOS. Again, Foundation, Core Data, Contacts, Addressbook. It's also necessary to note that all 4 platforms have Foundation as a shared framework to use. Because Apple shares frameworks across its SDKs, as developers, we can write core logic and features once and compile that code for each platform. Common functionality can be written once instead of being copy and pasted, effectively reducing redundancy. Similarly, since we don't have to duplicate code, we also don't have to duplicate tests or documentation. By creating modules of your existing code base, you are effectively separating concerns and uncoupling your code. This makes your code more maintainable in the long run as an added bonus. To demonstrate how easy it is to modularize and extend an iOS app's basic functionality to other platforms, I'm going to walk through a demo using the Gilt API. Gilt is an online shopping website in the United States based on flash model sales. At any given time, there are items on sale, and there's also a list of items that will be on sale. Gilt exposes a list of current and upcoming sales in its developer API. We will use this endpoint to create OS X, watchOS, and tvOS apps that list the names of each sale and display its pictures. So first, we write GiltKit, the API wrapper for Gilt that will be used in all 4 apps. Next, we need to create a new target for each platform. We can choose to do this all in the same Xcode project as GiltKit, or create separate Xcode projects for each target, and import GiltKit in each. I chose to do the latter here because it is what I would do for a larger project, since the method would make version control and scope more manageable, since each Xcode project can have its own Git repository. Also, to import GiltKit, I used Carthage. For the sake of time in this demo, I have already completed the first 2 steps. So here we'll focus on adding GiltKit to each platform and making the apps come to life using GiltKit to display the list of upcoming sales. By the way, here's a shortened public header for GiltKit. There are 2 structs here, client and sale. Theoretically, each resource on Gilt's API would have a corresponding struct, like sale over here. We would use a client to make calls to the API endpoints and retrieve these structs. GiltKit encapsulates all of the logic that has to do with response validation and theoretically error handling, etc. All of its logic is tested in one test suite in GiltKit's Xcode project. All in all, this truly separates concerns and makes client apps more lean and less complicated. In this demo, we'll use clients list sales for store in each OS to download the list of sales from the internet and fill our tables. So let's get started. So first, we're going to start with the iOS app, because that's what we're probably most familiar with. And we're going to import GiltKit into this app and fill this UI table view controller. This entire app is just one view controller, which is the UI table view controller. And if we run it right now, we'll see that it's just an empty table view. Great. So let's bring this, still loading. Cool. So let's bring this to life by downloading sales from the internet using GuildKit. So first what we're going to do is import GuildKit here. And we're going to need to use an API client to download these, and GuildKit already has it for us. So we're going to have a client here, like this. And we also want an array of sales to back the table view. So we're going to create a sales array, like so. And in the dit set, we want to also make sure that every time the sales array changes, we reload the table view. So we do this. Now, every time the view appears, we want to refresh the list of sales. So let's, in the view that appear over here, let's use the client to list all the sales for, let's say, the men's store, like upcoming sales. And this function returns an array of sales. So let's use this array of sales and just set it. Self.sales equals sales. Now, in order to make sure we're doing everything on the main queue, because this actually reloads the table view, let's also add a dispatch async, dispatch get main queue. And then also, in order to make sure that we're not running into any retain cycles by capturing a strong self, let's also create a weak self. And then add a question mark. Great. Now, in the number of rows in section, we want it to be just the number of sales in the array. So we do that. And then in the self row index path, we want to make sure that we get the sale at the current index path. And after that, we just want to set the URL to be the sales image URL. And we want the name label of this custom sale cell to be the name of the cell, the name of the sale. So sale.name. And I think that's it. Let's see it go. And hoping we have internet access, we should have something there. No? Let's see. That didn't go as planned. Okay, so view load being called. And view did appears in that case. That's really weird. But just, let's see if this works.
Are you using the sales view for the controller class? You wire it up in the storyboard?
Pardon?
Are you just using maybe the table view controller class and not this specific class? Maybe you didn't wire it up in the storyboard.
I didn't use storyboards here. Yeah. Yeah, I'm not really sure why. Maybe the dit set's not working or something. Pardon? Yeah, view load's being called. So view load's being called and nothing else. And it might be because we don't have internet. Not sure. Yeah, that's should have been done. Maybe not. Okay, so this is being called table view dot data source equals self. Actually, might be it. Play. Yeah. I'm definitely getting a data source. I'm not really sure what's happening. So let's skip the iOS one because it's the easiest one, and we'll go to tvOS. All right. Hopefully we'll have more luck over there. So let's go to tvOS and open up the app. Let's close the Xcode simulator for iOS. And again, you'll see is that we have, again, just one view controller for the entire app. And it's also a UI table view controller. And this is really cool because you never think that, at least when I first started writing this, I never thought that tvOS would also use the same exact UI table view controller that iOS does. So again, that's just same thing, import guild-kit, and create a client, just like before. And again, create a list of sales, var sales equals sale. And then in the did set, let's just reload the table view. And here, in view did appear, we're going to, again, call the list of sales. I have a snippet for this, because we've already done it once, and just for the sake of time. And again, over here, we just want to have the sales.count. And then right in the cell for index path, we want to make sure that we grab the cell by index, index path.row, and then we want the sale.image URL over here. And then we want to, so this basically like lazy loads the image in the cell. And then we want to set the name label to be it's the sales name. Perfect. Let's hope we have better luck with this. Otherwise, I think it's an internet problem. So it made the request for sure. I think it's an internet issue because we're not getting any data back. Are we having internet? Google.com, that will work. I don't know. Engadget. Yeah, I'm having internet issues. Cool. Well, we just trust that it works. I'll put screenshots up later, and also all this code is open sourced. So let's keep going. I'm going to then walk through how to write it on watchOS and also on macOS. Let's do macOS first. So let's open up a OS X, and again, this app is, well, let's run it before we do anything at all. And you see just a simple table view on the left, and then just a screen over here on the right. And again, what we're going to do is, so over here, as you notice, we have an NS view controller as opposed to a UI view controller. And that's because macOS has AppKit instead of UIKit. So everything is labeled with NS. There are a lot of differences in the two, but they're actually kind of converging. As of WWDC last year, they added things like view did load and view did appear to AppKit as well, which is really nice because now it's easier for us iOS developers to write Mac code. So again, we make a client just like before. And then we also create a list of sales just like before. And again, in the did set, we have an NS table view instead of a UI table view. So we just, NS table view has a similar API as UI table view. So you can just, again, just reload data on the NS table view. And, oh, well, we're getting errors because I forgot to import guild-kit right here. And then, again, in view did appear, we just want to list the sales. So we can just drag this right over. And then even the NS table view data source and delegate methods are relatively similar to UI table views, delegate and data source methods. So I can, again, just return sales.count over here. And then instead of cell for row at index path, we have view for table column. And same way, we can get the cell by reference. in the index path, or in the row over here. And then we set the URL of the image right here. And we can set the name label over here as well. And at the end over here, we can, so this is like, should select row is kind of like did select row at index path. And again, we can copy and paste, I think, both of these lines and replace this so that we get to cell by the row, we get the URL, we lazy load the image, and then we can set the name of the cell. So when you click on it on the right side, you'll see the name. Granted, it downloads. And then over here, sale.description. And let's hope something works. Again, it made the request. I can tell it made the request. It's not downloading, so despite all the code, you don't actually see anything. I'm going to let this just like be here, and maybe by the time I finish the next one, you'll see something here. OK, so let's not stop that. Let's work on the watchOS app next. And I just want you guys to realize as we're working through this that even though you can't see the data populate, it's really astounding how similar it is to use this framework and use all this code across different operating systems. Apple made this really easy because of the similar APIs that they all have, which, again, makes it really easy to, like, if you already have an iOS app and you already have modular code, why not also just like make an Apple Watch app if it makes sense, or an Apple TV app if it makes sense. And also, like, if you don't already have modular code, what this lets you do is actually forces you to kind of separate concerns and create modular frameworks so you can share them across all of your apps, which is really nice. So let's go back into the iOS app. We're going back into the iOS app because every Apple Watch app needs a host iOS app, so they're both in the same Xcode project. Let's see if I have any luck over here. No, not yet. OK, cool. So the Apple Watch app is, I think, by far the most complicated of the four. And that's because we have two view controllers over here. In WatchKit, they're called WK interface controllers. One is a list of all of the sales, and the next one is just like a preview of each sale. So you can see the image and the name as well as the description. So let's go into the sales interface controller. And again, a lot of it's the same. So we just do private let client equals client, private var sales equals sale. And over here, what we can do is actually in the did set, we don't have, so in a WK interface table, we don't have the concept of a table of view delegate or a table of view data source. You have to like basically supply all the information at once. So every time the sales array changes, we want to take the table view and set the number of rows to be sales.count. And then we also have like a row controller type, and we have the name right there, so we can kind of just take this constant, put it here, and then it knows to use the sale table row controller. So we also need to import guildkit. That's why the compiler is complaining. And cool. And now for every single row, we want to also set the name to be the sales name. So for the index in the sale, in sales.enumerate, we want to first make sure that we can grab the row. So gart let row equal tableview.row at index, row controller at index, and then index, else return. And then what we want to do is just set row dot name label. Oh, we also have to cast this to be a sale table row controller, because that's the custom table row controller we're using. And then sale.name label dot set text to be the sale.text. Sale.name, sorry. And that's it. And granted that the client call works, I'm no longer very confident about. Let's see. Well, let's see if this one worked. Oh, damn it. OK. So let's just run this, and you probably won't see anything at all. It's kind of a shame. Oh, wait, sorry. Wrong app. The Watch app now. We don't have Ethernet wire, do we? No. Oh, it's a huge screen. Oh, we do have an Ethernet. Oh, I don't have a connector. Yep, so we don't see anything because we're not actually downloading the list of sales from the internet. So I could go into, actually, yeah, let's just keep going. So if this were to show a list of sales, like it would just show the names of each sale. When you click on each table row, this function would be called, which is actually part of the WK interface controller. It's just did select row index path at index. And what we'd want to do is actually pass the sale as a context. So what we would do is like something like let sale equal sales index path. Oh, not index path, row index. And what we would think to do is kind of just pass the context in this way. But the compiler will complain because sale is a struct, and we have to pass in any object class. So we actually have to do is like create, what I would do is just create like a small little wrapper called like sale wrapper or something like that. And again, just import guild kit. And I think I have a sale wrapper. Just a really simple snippet. It just takes in a sale and saves it just to pass it along. And what we do is we can now, right here, just do sale wrapper and init it with a sale and pass it in. And done. Cool. And finally, this is the sale interface controller that has the photo, the name, and the description label. So in the awake with context, well, first we would want like a sale to back this view controller or this interface controller. So we have a var sale, which is of type sale. And again, we have to import guild kit over here as well. And what we're going to do is basically do guard. Oh, sweet. Okay. All right, now let's see what happens. Thank you. Let's see if we get any progress so far. No? Still making the call. Let's turn off Wi-Fi and try it once more. Pardon? What do you mean? Oh, they are connected. That's just Xcode being Xcode. And this is also different. We're looking at this one right now. Let's just check if the internet's working again. Try Engadget again. Still no internet. Oh, wait. Oh. OK. Well, let's keep going. No worries. So we're going to go into sale interface controller. And again, we passed the sale wrapper as the context. So what we want to do is kind of get the sale out of the sale wrapper. So what we want to do is get guard let sale equal context as a sale wrapper. We're going to cast it. And right here, what we want to do is get the sale, and else just return. I don't think I need this anymore. So then we just set self.sale equals sale. Perfect. Finally, now we can go in will activate. Will activate is kind of like you did appear when it shows up. This function's called. And just do guard let sale equals sale. else return. And that's just because sale is optional over here, just because at the time of init of this interface controller, we don't have a sale. And then we just set sale.text as well, sale.name over here for the name label. For the description, we just set this sale.description. And for the URL, we just set sale.image URL. And again, if we had internet, it would work. Can we go back to the deck? So, cool. Well, clearly, sharing code is powerful, especially if the internet works. It lets you write logic once and use it in many contexts. These contexts could be on different operating systems, or it could be on multiple apps on the same platform. For example, if I were to build the Facebook app and the Facebook Messenger app on iOS today, I would probably share at least one core framework to do basic things like download friends lists and represent user objects on both apps. Soon, we'll be sharing Swift code beyond just Apple's 4 operating systems. In December of last year, Apple open-sourced the Swift standard library on Linux. Since then, there's been a tremendous amount of work done to implement the foundation framework so that developers have access to classes like NSURL and NSState, etc. Developers are creating web servers using the Swift programming language. There are rumors that Google is considering making Swift a first-class citizen for writing Android apps. Imagine writing a single API wrapper and using it for your Mac, your iPhone, your iPad, your Apple Watch, your Apple TV, your Android phone, your website. Now that's really powerful. That's all I have to say. The demo I ran through is posted on GitHub, so if you guys do have internet, feel free to clone it. Thanks, everyone.
Dasmer,
Thank you very much.
thank you so much.
Of course.
Thank you so much.